flux, electric flux, heading down. Electric flux. So electric flux has a symbol phi and electric suffix e. Ready? Chalo, changa. Electric flux phi e. Phi means flux, suffix e means electric. Flux of any quantity is given by the quantity, that is electric field intensity dot area vector. You may write area vector to be A, or you may write area vector to be S, whatever you want. So let us write S vector. Here S vector is called area vector. Area vector. How can we understand area vector? Area to aaj tak we have been knowing area as a very gentle person, that is a scalar only. But area अपना रंग दिखाना शुरू कर दिया class 12 में. कैसे? It now proclaims itself as a vector. If this is an area, we understand that this area is, maybe suppose it is a circle of radius r. So its area S should be given by pi r square. Simple. We know this for long, since the history of mankind. We have been knowing this. The area of circle is pi r square, but area is vector. What if you are to write vector area like this? Can you write from this picture vector S? Vector is nothing but a combination of magnitude, that is value. So we have written the value pi r square, we know this, as well as its direction. What would be the direction of this area vector? Perpendicular to this plane and outward. अंदर का तरफ नहीं, बाहर का तरफ होगा. Perpendicular to this plane and outward. So we may assume this to be perpendicular to this plane and outward. अंदर का तरफ नहीं आना चाहिए, बाहर का तरफ जाना चाहिए. That means, and sometimes we try to depict any direction, unknown direction, any direction. I mean, not x-axis purely, not y-axis purely, not neither z-axis purely, by n. N means any direction. And by putting a cap overhead, we mean to say direction. So this is the direction. किसका direction? Of this area. So we can write value pi r square and then cap n. That means this is the direction and value pi r square. So this comprises this area vector. To know this in an easier way, we will be doing area vector later. Furthermore, first of all, let us understand this thing. So electric flux is given by E, S, and then comes dot product, that means cos theta. And we know in class 12 or 11, theta would always be, in class 12 especially, angle between two vectors. Whenever there is theta, think of two vectors. Vector 1 is electric field intensity, vector 2 is area vector. Electric field intensity is nothing but the direction along which field lines are drawn, acting in a region, field lines. So if we assume that these are the field lines, these are the field lines, these are the field lines, if I tell you that these field lines are parallel, what conclusion can you draw from here? Parallel field lines represent non-uniform electric field or uniform electric field? Uniform electric field, very good, that's it. So this is a uniform electric field, and suppose we have placed an area like this. The area is placed along which plane? This plane is what plane? Y-axis and Z-axis. So this is YZ plane. You have to be very clear with these things from beginning, class 12. Y and Z. So this is YZ plane. Perpendicular to Y and Z both is X. Come. Perpendicular to both X and Y is what? Perpendicular to both Y and Z is what? X. So the perpendicular, that is vector area, must be along x-axis. Now it depends कि x-axis का बाहर का तरफ होगा कि अंदर का तरफ, compared to this plane. If my hand represents this circular plane, then if you draw the direction towards me, that means you are coming inward. No, the direction has to be outward, perpendicular to this plane and outward. So vector area, wherever you have written this, please write perpendicular to the, yes, come, perpendicular to the plane and outward. This would be it. Perpendicular to the plane and outward. This should be the direction of vector area. Perpendicular to the plane and outward. Okay. Vector area. So the vector area here would be perpendicular to the plane and outward like this. So this is S vector. This is E vector. That means electric field. What is the angle between the electric field and area vector? 0 degree. We understand this. So electric flux here, phi E, is vector dot vector S becomes E S cos 0 degree, and cos 0 degree is nothing but 1. So phi equals to ES. समझे कि नहीं? Yes कि no? Yes, because the value is yes, है ना? चलो ओइखानটা বসে যাও। फिजिक्स बिना न्यूमेरिकल का होता ही नहीं है। चलो, write this. In a region, electric field is given by say 2I cap minus J cap plus K cap. Electric field intensity is a vector quantity. Some I, some J, some K. Electric field intensity. Okay. Now write a circular disk of area 2 meters square is placed along XZ plane. Find, right. Find electric flux through it, phi E. That is the question. Find phi E, phi suffix E. चलो, चंगा एकदम एनर्जी लगाओ. You have to do this. तो करो इसको अगर आंसर बनाना है तो स्टार्ट एग्जाम में ऐसे करना, जैसे कि ऐसे लिख के स्टार्ट करेंगे कि वी नो, एंड इफ यू डोंट नो देन राइट वी डोंट नो, बट लिख के आना है क्या कि वी नो फ्लक्स, इलेक्ट्रिक फ्लक्स इज गिवन बाय डॉट प्रोडक्ट ऑफ इलेक्ट्रिक फील्ड इंटेंसिटी एंड एरिया वेक्टर. नाउ we already know the electric field intensity given by this, already know this. So what else we know, we require to know S vector just. So let us write S vector. Electric field vector first लिखो 2I cap minus J cap plus K cap. हो गया ये. Dot अच्छी तरह से देना, dot, so that it becomes clearly visible, because यहाँ पे भी डॉट है, यहाँ पे भी डॉट है. डॉट ठीक से दिखना चाहिए, because these lines carry marks. Even if you get this wrong, the answer wrong, you will get half mark for each step. That is the technique. So हर एक स्टेप को ठीक से करना. तो ये हो गया वेक्टर ई. वेक्टर एस, वेक्टर एस का वैल्यू कितना है? 2 मीटर स्क्वायर. ये लिख दिए वेक्टर एस का वैल्यू, मैग्नीट्यूड 2 मीटर स्क्वायर. नाउ द डायरेक्शन ऑफ वेक्टर एस. वेक्टर एस का डायरेक्शन भाई साहब हो जाएगा माइनस जे कैप, माइनस जे कैप, ये हो जाएगा डायरेक्शन माइनस जे कैप. नाउ हाउ इज दैट? बिकॉज इफ यू वांट टू ड्रॉ द फिगर हियर, मैं यहां पे ड्रॉ कर रहा हूं, देखो कि इफ, ओ भाई तुम क्यों जा रहे हो? हाँ, इफ दिस इज एक्स एक्सिस, वाई एक्सिस एंड जेड एक्सिस. अच्छा, जेड एक्सिस को थोड़ा ऐसे करके ड्रॉ करता हूँ, पीछे कर. इफ दिस इज एक्स एक्सिस, वाई एक्सिस एंड जेड एक्सिस, जे, आई एंड के, then you know how this circular disk is placed, how this circular disk is placed, how should it look like when you draw it? Just roughly draw it. It should look like this. It is placed on the floor. Because what plane it is placed along? X, Z. So X and Z means this floor. If it involves Y, then only the plane would be like this, vertical, no? Then only. So it is placed on the floor. This is it. Now if it is placed on the floor is like this. This is the floor, this part. Now if it is placed like this, now perpendicular to the floor will be a direction, perpendicular to the floor will be a direction, that is perpendicular to the floor will be a direction that is either upwards or downwards. If you place something like this perpendicular to this, either upwards or downwards. Now upwards will involve origin with it, O, and this direction seems somewhat towards the or inwards, that term inwards, but the perpendicular direction must be outwards, perpendicular and outwards. That was it when we learned it here, perpendicular and outwards. So it has to be in this direction. ये blue color कहाँ से आ गया? हाँ. So the area vector here must be like this. This is vector S. How can we represent it? The value is value ram कितना? 2 meter square. 2. And the direction negative J. That's why I have written it here. You can also write it that first. एक बार ही सीखना पड़ता है, उसका बाद तो फटाफट फिजिक्स बस. दिस इज इट. हाँ बोलो. Sine. So if it is positive y axis, it is plus j cap. If it is negative y axis, it is minus j cap. That's it. That's why negative j cap. Now we know those who have forgotten the history of dot product. The simple thing is that dot product formula A1 A2 plus B1 B2 plus C1 C2. That means I cap J cap multiply and then K cap. So I cap नहीं है भाई साहब, इसका तो I cap है, but it is not blessed with I cap, बेचारा. Then J cap, yes, its J cap is minus 1 J cap and its J cap is minus 2 J cap. That is minus 1 and minus 2, J cap into J cap. So minus 1 into minus 2. So I cap nahi hai, 0, because it doesn't have any I cap. Similarly J cap, yes, the values we have extracted from that. And then K cap, that is again 0. Why? Because it has got some K cap, 1 K cap, but it doesn't contain any K cap. So its K cap value is 0. Come in. You may sit here or here or here also. So it is how much? 2. Flux is 2. Got this? E was given, S we had to find. How we found S? The magnitude was given, S, and the direction of area vector is perpendicular to the plane and outward. That means we will draw a perpendicular on the plane, and if we see that this direction leads to the origin, then we will avoid that. We don't want to go towards origin. We will move away from origin. So that sense will give us the direction outward, away from origin. Origin से दूर भागो. That is क्यों? Bombing चल रहा है origin में अभी, तो दूर जाना. Anyway, so this is 2. Now comes the unit. बताओ भाई, E का unit, electric field intensity, Newton per coulomb. And it is not that you have to let it go like कि okay ठीक है भाई सीख जाएंगे, देरी है अभी, ऐसा नहीं. You have to learn it right now. And if you think that no, I have forgotten it, earlier I learnt it, then write 5 times at the back of your copy कि Newton per coulomb like this. जिद होना चाहिए कि I'll do this, चल you will do this. If that is missing, then you will be missing something, because everything will not come common. No. If it is even me that I claim कि अरे सब कुछ common आएगा, don't worry, तो it may not happen. You have to prepare yourself that you may get 50% uncommon in the exam hall. Prepare like that. So then what? So to do uncommon things, first you have to get complete hold of the common things. And among them are these daily learning. That is, unit of electric field intensity, Newton per Coulomb. That's it. Just like that. Newton per Coulomb, yes. And unit of area, I know कि ये थोड़ा tough है, मैं बता दे रहा हूँ, meter square. So, anyway, so Newton per Coulomb into meter square would be the unit of flux, electric flux. So Newton per Coulomb into meter square. We did this in the last class, still we revised this. Newton per Coulomb into meter square is the unit of electric flux. And you should be prepared to find dimensions of electric flux. So many times it has been repeated in board exams. Okay. So nothing, dimensions of E into dimensions of area. Now dimensions of E can be found from this great formula given by Alexander the Great, given by our physics book, that is F equals to EQ. From F equals to EQ, we can easily find E equals to F by Q. F ml t to the power minus 2. Dimensions Q charge at. That's it. Okay. In physics, we may not remember everything that we are learning. This thick, flat book, we may not remember, but we have to be able to recreate that anytime we want. That will give you confidence. Okay, I can do this anytime. So F equals to EQ will always help you. So chalo, we have learnt the how to find flux. Now I am giving you one similar sum. Try to do that. Then you will get confidence. Yes, now I know that. Chalo, another similar sum, but this time draw this J cap, and if you have doubt, please ask me. I cap and K cap, because we would be having similar sums in magnetism, current, electricity again. So learn this better. Current, electricity would be easier for you. So draw I cap, J cap, K cap, and then draw this thing. This is an area. भाई ठीक ठाक हो जा, ठीक है चलो. This is 5 meter, चौड़ा, height 2 meter. This is an area. Give it a name. What's in a name? Well, POQR like this. What's in a name? So this is not English. There is a lot in a name. Some are born with it. Ambani, Tata, Birla, and some make it. So it's up to you what you want. I mean, where you place yourself. So anyway, so this name is no Tata Birla but OPRQ. This is the name of this area. This is an area, okay? So this is an area. This is placed like this. In an electric field, just I am giving the electric field, vector E equals to 3 J cap plus 5 K cap. So find the electric flux through this area. Electric flux through the area. Whatever you think, you may come out with your answers. Whatever you think. What is the electric flux? Yes? 0 is the right answer. Right answer. And I heard someone said it very instantly. Very good. And then if you can understand that, if you have that feelings, how it happens, other than these bookish formulas, then you can also answer it instantly. How is that? I am telling you. But first, let us do the bookish formula first. Then I will tell you the concept part. So according to formula that we know, and if you don't know, right, we don't know, but likh ke aana hai. We know what we know, that phi E equals to vector E dot vector S equals to, vector E is how much? 3 J cap plus 5k cap dot what would be the area vector? What do you think? The magnitude is how much? Length into breadth. How much is that? 10. Length into breadth. Now the area vector is placed along which plane? YZ, or you can say JK. JK दो चीज होता है, एक टायर होता है JK टायर एंड सेकंड इज दिस प्लेन. तो इसमें से हम लोग प्लेन को लेंगे. तो JK प्लेन में एरिया रखा हुआ है, JK प्लेन. सो परपेंडिकुलर टू दैट प्लेन वुड बी अनदर थिंग दैट इज x. सो वेक्टर एरिया would be like this. If you want to visualize it, how should it look like? Because this is the area vector and this is the perpendicular, this direction. This is the area because this is XYZ. So this is the area perpendicular to the area and towards the origin is this direction, but perpendicular to this area and outward would be this direction, avoiding the origin. Origin is inside, inside, this side. So this side is outside. So this would be vector area. How much would it be? 10 is the magnitude, 5 into 2, and the direction is along minus I cap, negative x-axis, minus I cap. So this is the answer. Dot 10 minus I cap. 10 is the magnitude, minus I cap is the direction. So A1 A2 माना I cap भाई इसका है इसका नहीं है 0. B1 B2 माना J cap इसका J cap नहीं है इसका है फिर से 0 and K cap इसका K cap है उसका नहीं है फिर से 0. So all are 0. So the total flux is 0. Now comes the understanding part. The understanding part is, see, area vector would be only along a certain direction only. Certain direction means either I, नहीं तो J, नहीं तो K. If it is placed along IJ plane or JK plane or IK plane, these are the three planes, then just multiply perpendicular value. Like यहाँ पे क्या है देखो, 3J cap, 5K cap, but area vector is along minus I cap. So if you multiply these two on a dot product, then it would be 0 because it would be I cap 0, J cap 0, K cap 0. And in another meaning, I am showing you the concept part. The concept is this thing. See, if these are field lines, that means electric field. If these are field lines, that means electric field. And if we place an area like this, these field lines pass through this area, then come out of it. मोटा मोटी straight line, हाँ please, इसको मान लो कि straight line है ऐसे. And then you did what? You got another plane like this, but this time the plane is tilted like this. Same length but tilted somewhat. So do you think that same flux will pass through this? No, because some less number of field lines will pass through this. Why? Because some flux will manage to escape that from below and some flux हो गया बस, manage to escape from top above it. I was thinking कि if that hits this area, अरे problem हो जाता. हाँ, ये तीनों का ठीक है भाई. These are passing through that area. Okay. And now, if that same plane is made like this now, सो गया बेचारा, tired था. The area was very tired and the area is lying here along the which plane? X and Z. Yes. Now, where are those field lines? आ जाओ भाई. भाई तू तो साथ निभा दे. नहीं, तू, मैं तो ऐसे ही बाहर था. अच्छा, तेरा क्या होगा अब? मैं तो दूर हूँ, ठीक है, सबका बहाना है, बट नो फ्लक्स इज पासिंग थ्रू दिस एरिया, नो फ्लक्स. चलो, व्हाट इज द मीनिंग ऑफ फ्लक्स? नंबर ऑफ फील्ड लाइन्स passing through an area perpendicularly or normally. Number of field lines passing through an area. Easy idea. This is an area. How many field lines are passing through it? This is called flux, electric flux. How many electric field lines are passing through this? Now, if you make the area perpendicular to this flux or electric field, then maximum flux will pass through this. But as you start doing this thing, if suppose this is the area, and this is the field lines, these are the field lines, then maximum field lines will pass through this because it is held perpendicular to this. Now, as you start tilting this, some field lines will manage to escape from top, some from below. So, if you make the field line like this, I mean area like this, then no flux will pass through this. Some flux will pass above it, some flux will manage to pass from below it. Now, you may ask, what if some flux hits this thickness? That will to pass through this, but we are discussing plane. Plane means lamina. That is how 2D. Lamina means 2D. Thickness of 2D is 0. So, if it doesn't have any thickness, how can any flux manage to pass through the 0 thickness? So, no flux manages. That means flux becomes 0. If you place an area like this, ऊपर से नीचे से, no flux will pass through this. Net flux 0. Maximum flux like this. Now, Gauss is a genius person. Gauss's theorem is this: electric flux. पहले हाई फाई चीज सीख लो, उसका बाद इसको सिंप्लीफाई कर देंगे, हाई को काट के सिंपल लिख देंगे. हाई फाई टू सिंपल, पहले हाई फाई. इंटीग्रेशन पेड गोल माना सरफेस इंटीग्रल, ऐसा है उसका हिंदी टर्म है पेड गोल. तो इंटीग्रेशन पेड गोल, नीचे एस, राइट ई डॉट डी एस, स्मॉल एरिया ई डॉट डी एस. This is not Gauss's theorem, I'm telling you. This is not Gauss's theorem because this part is mathematical part. To find flux of any quantity, magnetic, electric, gravitational, this part is common. So, can there be a Gauss's theorem in gravitation? That has also got some field, gravitational field. So, Gauss's theorem applicable for gravitation? Yes. That is also applicable for gravitation, and there may be a question from a short question because we had gravitation in class 11. So, later we will be doing that. First, let us learn it in electrostatics. So, this is surface, S means surface, integral of dot product. This is dot product of which vectors? Electric field and area vectors. Is, now comes Gauss's theorem. He simplified this. This is not simplified. Now it is simplified. This is Gauss's theorem. What? 1 by epsilon naught times the charge enclosed by a boundary. QEN means enclosed charge. Q for charge, EN means enclosed. By what? By a boundary. And that boundary is called Gaussian surface. Remember, Gaussian surface, two-dimensional, not one-dimensional. Boundary may mean one-dimensional. If I draw this boundary, this is one-dimensional, line only. But Gauss's theorem is not one-dimensional, it is two-dimensional or maybe three-dimensional. That is, maybe three-dimensional. Surface area. This surface should be Gaussian surface. That means what? Gauss says that if you want to find electric field, electric flux, draw a Gaussian surface through the point. मैं लिखा दे रहा हूं, सुनो. तो Gauss's theorem से हम लोग क्या फाइंड करते हैं पहले वो देखते हैं. What do we find from Gauss's theorem? Gauss's theorem is applied to find ये इलेक्ट्रिक फील्ड इंटेंसिटी. तो ऐसे फाइंड कर लेते दूसरा फॉर्मूला करके. हाँ, you could have done that, but that would have been a lengthy process involving complex mathematics. Gauss's theorem does that in one or two lines. That is the beauty of the equation. Okay. So Gauss's theorem is applied to do what? To find electric field intensity. Second thing, to apply Gauss's theorem, we need to do what? We need to draw a surface. ये सरफेस कैसी होनी चाहिए? और चार्ज डिस्ट्रीब्यूशन कैसा होना था बोले थे? चार्ज डिस्ट्रीब्यूशन सिमेट्रिक. So surface should also be symmetric. So we should draw a surface which is symmetric about किसका रिस्पेक्ट में? चार्ज डिस्ट्रीब्यूशन about the charge. चार्ज है ना, ऐसा लिख दो चार्ज डिस्ट्रीब्यूशन about the charge distribution. लिखते रहो. Write the points. Write the points because more you write, इसमें एक तो लाभ होगा ही होगा कि एग्जाम में बहुत हेल्प होगा, पढ़ने में हेल्प होगा, दूसरा क्या होगा? मसल बनेगा भाई. लिखते रहो. तो you have to draw a surface, but how to draw a surface? Where to draw this surface? Anywhere? No. That idea you need to understand. Surface about the charge distribution, and let me add another thing, and don't give full stop, huh? And passing, this is for students understanding, not for writing in the exam. Student understanding, student, and passing through the point where we have to find. Now comes the term. We have to find. What we need to find? What we find from Gauss's theorem? Which quantity? Electric field. So where we need to find electric field intensity, E. That is the concept. So Gauss's theorem must pass through. It underline करके रखो उसको. Gauss's theorem must pass through. Underline करके रखो. कहाँ गया? Hey, Gauss's theorem बोल रहे हैं. Gaussian surface. Gaussian surface that is symmetric must pass through the point. It must pass through the point. Then, okay, we understood how to draw this. And another important point from which many years questions have been coming, that is another point. The electric flux, that is phi, does not depend on the size of the Gaussian surface on the Gaussian surface. Size of the Gaussian surface, it doesn't depend on that. We'll clarify this later. But after knowing this, let us now do that calculation part first. Let us understand how to apply this. Write a question like this. Write a question. Find flux through a charge of 1 microcoulomb. How much flux will come out of 1 microcoulomb charge? Because if there is a charge, there will be electric field lines away and away from plus charge. And for minus charge, we did this. For minus charge, field lines move or culminate towards the negative charge. Field lines come towards the negative charge, but for positive charge, field lines move away from the positive charge. Okay. How many field lines move away from or generate from a charge? That is Gauss's theorem. So, flux means number of field lines coming out of it, a charge. सिर्फ Gauss's theorem वाला right side को बैठाओ. Right side, that is 1 by epsilon naught into q. That was it. 1 by epsilon naught into q. So just let us put the value. How much is q? 10 to the power minus 6. 1 microcoulomb. Microcoulomb is 10 to the power minus 6 coulomb. divided by epsilon naught, 8.85 10 to the power minus 12. We did this earlier. A student is not supposed to remember this, but I would suggest कि for board exams, try to remember this. Epsilon naught, that was electric permittivity of free space. But I also told you in the last class that if you can remember 1 by this value, 1 by epsilon naught, then that will be very helpful for you. 1.13. Very good, you remember that. So tell me that value, 1.13 10 to the power? But here, only 10 to the minus 12 will become 10 to the power 11. This thing will become only this thing. 1 by 8.85 10 to the minus 12, that is 1 by epsilon naught, will become this much. 1.13 into 10 to the power 11 into, then this value is there, 10 to the minus 6. एक बार चेक करके देख लो तो इसको 1 by 8.85 into 10 to the minus 12. एक बार चेक करके देख लो तो 1 by 8.85 कितना आ रहा है, देखो देखो. So it is 1.13 10 to the power 5. Now unit of flux again, Newton per coulomb and meter square. So this is the flux coming out of 1 microfarad, 1 microcoulomb charge. This amount of flux will come out. Okay. Now flux may be positive or negative. Next page चलो, फटाफट लिख दो. Next page लिखते रहो. Flux may be positive. This may come in assertion reasoning type questions. May be positive or negative. How? Let us understand this. Let us draw a shape, any shape like this. Suppose you have picked up a stone from a roadside. Okay. So draw any shape like this and then place it inside somewhere where there is an electric field like this. This is electric field. How is the electric field? माने good ना bad, लंबा ना नाटा, वो सब नहीं पूछ रहा हूँ. Electric field is uniform ना non-uniform? क्या लग रहा? Uniform, because parallel field lines. Okay. So this is electric field lines. Uniform. ऐसे, ठीक है? Now what will happen? Field lines, जितना निकला था ना field lines, बीच रास्ते पे कोई मिला, कौन? Cheap stone, या तो this पत्थर मिला, ये this stone, or suppose this is a metal, anything. So if it meets somewhere, the field lines strike that. Field lines are imaginary. We assume that field lines will strike that, and then after it ends, field lines again start from that other end. Field lines. Okay. So these field lines will start from here again and become like this, like this, like this, and like this. कम हो गया क्या? Like this. So draw them. Drawing them will also clear your concepts, because when you find questions with these pictures, it will give you confidence. Okay. Now comes this thing. Draw a tangent at any point on this side. So I am taking this convenient point, this one here. I am drawing a tangent here. If you also draw a tangent, that should also look like this, somewhat like this, tangent. I am drawing a small area on this cheap stone, और जो रास्ते में पत्थर मिला या तो कंडक्टर मिला, उसके ऊपर स्मॉल एरिया कंसीडर किया, पेनी शेप ऐसे करके. ये स्मॉल एरिया का नाम दे देंगे ds. स्मॉल एरिया का नाम दे देंगे ds. नाउ आई एम एडिंग टू थिंग्स विद ds. टू थिंग्स टू ds. क्या क्या दो थी? If this is 0.1, so I am writing ds1, and if I want to give the direction of this area ds, ds is the small area here considered, a patch of area only, ds. What would be the direction of ds? How do we represent direction of any area? perpendicular to the plane. So area vector ds1 will be like this. ds1 matha mein arrow. So I am erasing this ds1. This suits better. ds1 area vectors. Similarly, if we take another point here, say here, we may draw another tangent here like this. And we can consider another small area here. This may be ds, अच्छा यहाँ पे नहीं लिखते, it may be ds2 ऐसे, ds2, and we may consider any area here also. This would be ds3. But as you are putting arrow, give an arrow overhead to represent it as vectors. So this is ds3 vectors. So ds1, ds2, ds3 vector drawn. Now, fatapat, up, fatapat. Last day I had explained, otherwise I am telling you, do you remember that angle between two vectors? This is a vector, say vector A, class 11, and this is a vector, say vector B. And if this angle is say 120 degree, then what is the angle between vector A and vector B? The answer is not 120 degree, 60 degree. Because the idea was head or tail. Remember that. A vector has got head here, arrow head, but B vector has got tail here. So the angle between head and tail will not be taken. Then the exterior angle has to be taken. ये angle को लेना है फिर. ये कितना हो जाएगा? 60 degree. তাহলে হেড টেক দ্য অ্যাঙ্গেল। এইখানে কি আছে বলতো, আমার ফিঙ্গার দুটোতে টেল यहाँ पे क्या है? टेल दिस वेक्टर हैज गॉट इट्स टेल बिकॉज दिस इज हेड, दिस वेक्टर टेल टेक दिस एंगल थीटा। ओके, हेड दोनों वेक्टर टकरा रहा है, टेक दिस एंगल थीटा। ओके, बट हेड एंड टेल डू नॉट टेक दिस एंगल एज थीटा। तो क्या करना है, इसको आगे बढ़ा दो एंड देन कंसिडर दिस एक्सटीरियर एंगल। ओके, so with this vector idea, do you understand that simple, ज़्यादा डिमांड नहीं है इसका, simple idea that area angle between this electric field intensity, तो हमारे field line electric field intensity is along this. Electric field intensity किधर है, which direction? Along positive x axis, सामने। एरिया वेक्टर किधर है, पीछे। सो व्हाट शुड बी द एंगल बिटवीन द एरिया वेक्टर एंड इलेक्ट्रिक फील्ड इंटेंसिटी? इज इट एक्यूट एंगल और ऑब्ट्यूज एंगल? ऑब्ट्यूज एंगल, बस इतना समझ में आना है, वैल्यू नहीं चाहिए। सो दिस एंगल थीटा 1, बिकॉज दिस इज द फर्स्ट पॉइंट, सो थीटा 1 इज ऑब्ट्यूज एंगल, ये लिख दो। और उसका साथ ये भी लिख दो cos थीटा 1। अच्छा, ऑब्ट्यूज एंगल मोर देन 90 डिग्री, cos थीटा प्लस ना माइनस, नेगेटिव, सेकेंड क्वाड्रेंट, cos थीटा becomes negative like cos 120 degree minus half. So cos of obtuse angle would be negative. चलो ये समझ में आया। Second thing, what about this point 2 where the area is ds2? ds 2.0 मत लिखना, 2 लिखना, अभी मूवीज का जमाना है। तो 2 ds2, तो ds2 would be having acute ना obtuse? Acute angle, very good, acute angle. So this theta 2 would be acute. Theta 2, electric field positive x axis, theta 2, area vector and electric field vector acute. So cos theta 2 would be plus or minus, positive or negative? Positive. Acute angle though, positive. What about this? This is the direction of electric field, positive x axis. Achha, if electric field is here E, vector E here, everywhere electric field intensity will remain same. Yes, because its magnitude and direction both are constant, because we initially declared that the electric field is uniform. That means what? At every point electric field vector has same value and same direction. So this is also vector E, right? Okay. What is the angle here? Deliberately we have taken it 90 degree, deliberately, so that 90 degree, so that cos 90 degree is 0. Okay. Now see the मजेदार result of this. क्यों ऐसा किए? Result of this कैसे? So flux phi incoming when flux hits a body. You have been seeing movies, अगर ऐसा देखे हो movies तो जब बॉम्ब गिरता है ना कहीं पे, then military says incoming बोल के चिल्लाता है, मतलब bombs are coming. So here flux incoming, माने field lines are coming. So that point may be where? Here, anywhere where the flux is entering the body, on the left side of this irregular shape even. Anywhere the flux is incoming, ठीक? So incoming flux E ds into cos theta था, तो cos theta plus ना minus, positive or negative? Negative, because the angle is obtuse. So into cos theta would be negative. So ultimately we are not interested right now with the values, but sign. So what do we understand? That incoming flux is negative. Clear understanding? Book में ना एक line में लिखा हुआ रहेगा बस. Now there is a single option for you. Just remember it. How many such lines will you remember? You cannot. तो उससे अच्छा समझ लो, incoming flux negative for same reason. Flux outgoing flux, this flux E ds, so जो भी होगा ds cos theta plus ना minus, cos theta plus, so the flux will be positive. और इस पॉइंट का नाम अगर 3 दे देंगे, 3, so phi at 3 would be how much? 0. No flux, and that will mean what? No flux means what? At this point 3, कहाँ गया? ये this point 3. No flux means what? The flux will be passing, just touching it, but without entering the surface. So copy लेके दिखा रहे थे कि if the flux avoids a surface, then the flux through a surface is 0. So at this point no flux will pass through this, because flux is like this and the surface is also like this. So flux will manage to escape. ठीक है? Net flux will be 0. And especially when will it be 0? Theta 90 degree. Theta 90 degree does not mean the plane is 90 degree. Theta is the vector area 90 degree. Now look at this. If I take another plane, because the background is black though, I'm taking another pen of different light color, yellow or any other color. You have got yellow, green, yellow. Oh, okay. अरे चाकू, क्लास में चाकू आ गया. अरे ठीक है, this is okay, good, this is good. क्लास में चाकू आ गया. अच्छा, anyway, तो suppose if it is like this 90 degree, if this is the area vector, so sorry, this is the area vector. Now if I want that the theta has to be 90 degree with this electric field intensity, this is electric field, so is it correct orientation of the area that theta is 90 degree? What do you think? No, this is that correct orientation, that theta is 90 degree. Theta is the angle between which vectors? Electric field E and area vector S or ds. This is now 90 degree. So when area vector 90 degree, but area is parallel to the electric field. Area is parallel to the electric field like this or like this. Area vector 90 degree. No flux passes through that area. आधे ऊपर से आधे नीचे से, बाकी इसमें से जाएगा. अब जितना बचा तो anyway चाकू ले लो भाई. So we understand incoming flux, outgoing flux. Now, so if we have understood incoming and outgoing, so let us do this. This is the box. This is a Pandora box. It may give you anything you want. This is a box. And it is given that it is placed along थोड़ा सा लेवल थोड़ा सा धीरे धीरे आप करेंगे. This is origin O, ठीक है, O, and this is x axis, this is y axis, and this is z axis. This is electric field intensity. How much is that? This has got a value E naught, fixed value, and direction I cap, x axis. Let us give this cube a name. This is a cube. This name is, say, A, B, C, D, and then O, P, Q, R. Cuboid or cube has how many vertices? 8. ये रूम का ऊपर वाला 4 कोना, नीचे वाला 4 कोना हो गया. Total 8 points. So give 8 names. A, B, C, D, P, Q, R, S. But एक तो O ले लिए. That's why O, P, Q, R. Okay. Now, तुमको ये निकालना है कि फ्लक्स, अच्छा वैल्यू दिया हुआ इलेक्ट्रिक फील्ड का, एंड दिस क्यूब हैज ईच साइड, ये लिख लो, क्यूब हैज ईच साइड इक्वल्स टू ए नॉट, स्मॉल ए नॉट. चलो तुमको क्या निकालना है? फ्लक्स थ्रू ए बी सी डी, फ्लक्स थ्रू नीचे कौन है? पी, ओ पी क्यू आर, फ्लक्स थ्रू फाई, इसको ले लो कि डी सी क्यू आर, फ्लक्स थ्रू इसको ले लो कि ए बी पी ओ, ये सबका फ्लक्स निकालना है, ये सबका. तो देखो एक बार ट्राई करके, इफ यू कैन अंडरस्टैंड द फ्लक्स इज हाउ मच, इलेक्ट्रिक फील्ड इंटेंसिटी वैल्यू को तो ई नॉट into area into cos theta. How to find theta? The angle between electric field intensity and the vector area. Vector area how to find? Perpendicular to the area and outward. That is the big. Now try this. 4 flux are to be found and 3 minutes are given. Chalo, you are given 3 minutes. Try this, try this. देखो इसको समझने के लिए टेक योर लेफ्ट हैंड, राइट हैंड से मत करो इसको, लेफ्ट हैंड लो, उसमें ना ऐसे ही करके उसको गोल घुमा दो, देखो एकदम परफेक्ट आंसर आ जाएगा. नो फ्लक्स विल पास थ्रू दैट, नो फ्लक्स थ्रू एनी ऑफ द एरियाज रिटन हियर, बिकॉज फॉर एवरी केसेस थीटा इज 90 degree. That's why I told you understanding comes first, then goes other things. So I was searching for this. He has got this box here, and I got this thing also. This was for class 9 experiment, but okay, this will do. See, if this is the, अच्छा नाम नहीं दिखाएंगे, if this is this cube, vector area of this surface, cube has how many surfaces? 6. Front surface, let us call it, and let us give it the name DC cube R. This is DC cube R. Okay, vector area perpendicular to this outward, ना कि perpendicular to this inward. क्या होगा? Outward. So this is this vector area of the front surface, DC cube R. And what is the direction of electric field? Electric field x-axis. What is the angle between electric field vector and this area vector, red arrow? 90 degree. What is cos 90? 0. So flux equals to E ds, area of this, into cos theta, angle between these two, that is cos 90. So 0. No flux will pass through this. So if any surface is parallel to this electric field, no flux will enter here. ये तो टॉम एंड जेरी नहीं हो रहा है कि इधर आया फ्लक्स, देखा अरे सरफेस तो इधर है, फिर बेंड करके इधर चला जाएगा, ऐसा तो होगा नहीं. So no flux will pass through this, like this it will pass. Okay, same thing will happen for this surface as well. This surface, this is also vector area. It cannot be inward. Why? It should be perpendicular and outward. ये छद का surface, छद कौन सा? ABCD. So electric field intensity along this, electric field intensity, ठीक? So angle between electric field intensity E and ds is 90 degree again. So flux is again ES cos 90, 0. Same for this also. This surface will be having area vector perpendicular to this and outward, है ना? So this will also be having electric field intensity and area vector 90 degree. So 4 surfaces will be having 90 degree area angle with electric field. X axis का साथ 90 degree में 4 surfaces है. एक तो ये, क्योंकि सोचो ना, x axis यदि electric field, if the electric field is x axis, तो this is z axis 90 degree minus z axis पीछे 90 degree, दो हो गया दो. अच्छा, this is y axis 90 degree with x axis minus y axis 90 degree with x axis again. So all these 90 degrees will give you 0 flux. हो गया ना? Only 2 surfaces remaining, 2 surfaces which will be having angle between the vector area and electric field 0 degree. They will give you flux, and those are what? First front surface, this one. मैं सिखा था ना, जहाँ पे इलेक्ट्रिक फील्ड परपेंडिकुलर ऐसे हिट करता है विद द सरफेस परपेंडिकुलर, वेक्टर एरिया नहीं, सरफेस का साथ परपेंडिकुलर, वहाँ पे मैक्सिमम फ्लक्स जाएगा. सो मैक्सिमम फ्लक्स यहाँ पे जाएगा. तो ये फ्लक्स इनकमिंग है कि आउटगोइंग है? इनकमिंग फ्लक्स पॉजिटिव ना नेगेटिव? नेगेटिव फ्लक्स. एंड हाउ मच वुड इट बी? द एंगल इज, this is electric field intensity, this is vector area. Vector area negative x-axis, electric field intensity positive x-axis. 180 degree, angle is 180 degree. Okay, so these 4 are 0, and then flux through incoming surface is this, I mean to say, this area. This is what area? dA and then OR. dA/OR equals to electric field intensity. What is the magnitude of this? तो E नॉट इंटू, वेक्टर करने की जरूरत नहीं, डायरेक्ट कर सकते हो. वैल्यू कितना? E नॉट. और परपेंडिकुलर एरिया, ये तो परपेंडिकुलर हो ही गया है. एरिया कितना? A नॉट इज ईच साइड इज A नॉट. सो द एरिया इज A नॉट स्क्वायर. साइन पॉजिटिव की नेगेटिव? Negative, because this is incoming and outgoing. Incoming flux is always negative. So this is negative. You can write this directly, or those who want to go by the books, then that idea is this, कि this flux could have been written like this: phi equals to vector E dot vector S. You could have written like this also. Vector E was E naught I cap dot vector S. What is vector S for? Vector S for ADOR by arrow. This surface perpendicular, area तो A naught square, area, and direction inward and outward, outward. So direction is minus I cap. Direction of this vector area would be minus I cap. So direction is minus I cap and area is A naught square. Direction is minus I cap. भाई और कितना ब्रैकेट देंगे, ब्रैकेट के अंदर ब्रैकेट. So anyway, so let us take the values first. Values are E naught and A naught square. लिख रहा हूँ E naught and A naught square, and then I cap dot minus I cap. This is minus 1. Why? थोड़ा सा वेक्टर क्लास 11 का I cap dot I cap कितना होता था? 1. J cap dot J cap कितना होता था? 1. Similarly K cap dot K cap 1. So I cap dot minus I cap, भाई एक माइनस आ जाएगा, नेगेटिव. तो सेम आंसर देखो, बिना वेक्टर अप्लाई किए वेक्टर अप्लाई किए. So whatever you think confident, you do that. So this was very helpful. बना बनाया था हाथ में. That was very helpful to understand. You also try to understand like this. Whenever you think later with these things, try to understand like this. These are the vector areas. Okay. So that was it. But last one is remaining. ये तो हो गया phi DAOR. Last one मैं कलर चेंज कर लेता हूँ. Last one is phi. हाँ, this surface, the opposite to that. Say BC QP. Electric field intensity E naught into the area. The area is how much? A naught square. And it is plus because the flux would be moving out of it. The outgoing flux is positive. For that also you can do plus, or you can go with that vector idea again. That will also give you plus. So flux incoming negative, flux outgoing positive. But of same value, दोनों का value same आया. So if it is asked that flux associated with the cube, यहाँ पे एक स्टार देंगे, तुम लोग नीचे लिखो, मैं ऊपर लिख रहा हूँ, तुम लोग नीचे लिखो. Flux associated with the cube equals to total flux. So a flux of this surface plus flux of that surface, this surface, that surface, all the 6 surfaces taken together, adding them, by चारों तो खुद 0 है, these 4 are themselves 0, and 2 are Jani Dushman, means positive and negative. That means if you add them, they will cancel each other. So ultimately total flux would be 0. Total flux is 0. Now what, ठीक है, ये तो सीखे, but for this example, what is the charge inside this? Gauss theorem apply कर रहा हूँ. तो from, एक बार लिखो तो, from Gauss theorem से क्या मिल रहा है देखो कि this flux जो भी मिला total flux must be equal to Q enclosed by the Gaussian surface divided by epsilon naught. Now we got phi itself is 0. 0 आ गया total flux through the enclosed surface. कौन है? This box. This box is a surface that is enclosing something. इसका अंदर कुछ है, क्या है? Charge. It will be enclosing some charge. तो अगर phi 0 है, if phi becomes 0, तो 0 into epsilon naught will give you 0. So Q enclosed is 0. No flux, no charge is inside that cube. No charge is there. So if net charge of a body, net flux of a body is 0, no charge is inside that. But if some charge is inside that, there would be some flux. How much that flux would be? इतना होगा, इतना ये तो if there is some charge, we did this some earlier, a body was having this charge, तब कुछ flux होगा इसका इतना कैसे है ये q by epsilon naught, and if the flux is zero there would be no charge inside that body. That is it. If you can ये बचते if you can understand this कि total flux is zero through this cube, total flux inside, you may go through this main sum when mains used to be IIEE in earlier stages, mains engineering IIEE, then this sum came what now phi 1 दिया हुआ है, and new days abhi you can have the same sum, similar sum in other ways. Let me make it assertion reasoning or some other way. Say the statements, statement 1 बोल रहा है कि phi 1 equals to flux मतलब electric flux entering a cube. Let phi 2 net flux leaving the cube. This is a given. Then question क्या है? Question बना देता हूँ. Question is charge inside the cube is how much? This is the question.
Leaving positive. Phi 1 minus phi 2 minus phi 1 is equal to 0.
So this is the net flux that should be equal to Q enclosed by epsilon naught. So Q should be equal to epsilon naught into Q1 minus Q2. Sorry, phi 1 minus phi 2, not Q. Phi 1, phi 2 minus phi 1. Oh no, they were only values given. They consider them to be values only. That's why it was there. Anyway, but the answer is similar to that. Oh, okay. So phi 1 is the flux entering a cube. If these languages are given, then always consider that they will not give you the signs. You have to put the signs. Class 12 is a solid applications of signs, where one to here we can see. Then in light, optics, lens has focal lengths, lens has power, mirrors have power, positive, negative, focal length, real image, virtual image. So signs are important in class 12. So sign about this is entering is negative, flux entering, flux leaving is positive. That's it. So entering negative phi, leaving positive phi, then total, just add them. Scalar quantities, so they can be added only. Add them, this is the total flux equals to Q by epsilon naught. So Q would be epsilon naught times this. Okay. Second part, we are going with this thing. Suppose if a flux, if a charge is placed somewhere, then let us draw this. Spherical charge or point charge will release these field lines from it in all directions. In 3D, 3D means steradian, solid angle, steradian, 3D, spherical or radial directions like this, every direction. From Q charge, flux will move like this. Okay. Now, if you place this Q charge, let me show this Q charge with a different, like this, Q charge. Now, if you have this Q charge here, this is a hemispherical container or hemispherical shape. So, this is a hemispherical. Hemispherical container or shape or structure like this, hemispherical. That means you understand this, hemispherical like this. Now, a charge is placed like this, here at the center. Q charge is placed. Now, the flux through the hemisphere that would be half Q by epsilon naught. Now, these don't involve mathematical calculations. This involve your understanding only. Flux means all the field lines coming out of it. Now, every plane of this surface, hemisphere, every plane is so thin, thinner than the page you are writing these on. Very thin. Compared to them, the charge is sizable. Compared to a thin plane, that is this base of this hemisphere, the base bhi to circular hi hoga na hemisphere ka, then to comes the hemisphere above that. So that base is so thin, patla, so thin that even if a charge is placed at the center of that hemispherical circular plane, the base of the hemisphere, circular plane, then half of the charge will peep out of this plane and half of the charge will be inside. From now on, let us think charge to be sizable enough so that if we draw a plane at its center, half of the charge will remain above the plane, half of the charge will remain below the plane. From now on, let us think charge like this. So the theories will be very easy for you then. So if you place this charge, I have deliberately drawn this charge in a manner so that half of it is above this line and half below. So you can understand, and it becomes very easy to understand, that half of the total flux coming out of it goes inside this sphere and half of the flux they move outside the sphere like this. ये खराब हो गया picture. This was better. चलो ठीक से. Half of the flux will go inside because the charge is placed 50-50. Now, if that same thing is given like this, charge placed here, where at the base of a cube, located centrally. Do you understand how should the figure look like? It should look like this. It should look like this. Chalo, ye raha cube. And this is it. पूरा क्यूब तो हुआ नहीं, ये थोड़ा बड़ा हो गया. चलो ठीक है. And the charge is placed on the base of the cube and at the center. On the base of the cube and at the center is here. Base of this cube is this and at the center is this. So here is placed the charge. So the charge is placed somewhere here at the center. Though it doesn't look like that center. Next page में करता हूँ हाँ. Let me draw a bigger picture. तब भी अच्छा नहीं हुआ, but better than that here at the center. So it can be said that at the center of the base, take charge is placed, Q charge. So flux through the cube what would be the flux through the cube? What do you think? Flux through the cube. What fraction of the flux will pass inside the cube? Huh? Half. Yes, half of the total flux, Q by epsilon naught. Half of the total flux. Why? Because initially we did one thing, that is, flux does not depend on the shape or size of the Gaussian surface. So here the Gaussian surface has become cube. Previously it was hemisphere. The idea तो same ही है ना कि charge is somewhere. Suppose this is the charge. It is placed at the center of some surface. That surface, be it hemispherical, above क्या है, that doesn't matter. That doesn't decide कि how much of flux will enter. What decides is charge का कितना fraction cover किया हुआ है. If you have any surface where charge is placed, then half of the charge will move inside, half of the charge will keep itself outside. So only half the flux will enter, the whatever is placed above it, only half the flux will enter, and remaining half of the flux will come out of it without entering that shape. Whatever shape it is, if you suppose do this, कि ये shape को ना ऐसे कर दिया, ये माथा का shape को ऐसे कर दिया, ऐसे कर दिया, और छद ऐसे, then also same result remains, because base तो same ही रहा ना, covering half of the or taking half of the charge inside and half of the charge outside. So half of the charge, that means half of the flux will enter inside, half of the charge will move outside. That is it. So this is half of the charge, half of the flux. Now I am drawing another picture here, and धीरे धीरे things will get a little tough. To imagine only, not to answer. Answer easy. And that is, this is the cube again, and this time we are taking the charge at the center of the cube. Let us call this position 1, center of the cube. That means the charge is completely inside the cube. मान लो कि ये room जो है ना, ये room ही cube है, and you have taken the charge at the center of this room. Or suppose you have taken the charge inside this cube. ये cube है, cube का inside में middle point में है, at the center. Oh भाई, at the center charge. Then you have covered it. So charge is at the middle, center. So all the flux are bound to hit these walls because the complete charge is inside. So the flux through the cube is complete Q by epsilon naught. Whatever flux comes out of it, total flux will be inside the cube. ठीक. And in that case, ये point 1 नाम दे देना तो इसका point 1, and in that case flux through any surface, पूरा क्यूब में से तो flux total complete flux will enter, but through any surface, like if you have placed the charge inside, through this surface how much charge, this surface how much charge, this surface how much charge, because if you have placed this charge inside this, then all the flux will hit the walls. Mane, if suppose this is the room, so at the center you have placed a charge, then from this charge there will be flux coming out of it, and they will hit this wall, this ceiling, this floor, that wall, this wall, like this. Now if the charge is brought at one side of this room, close to one side of this room, then most of the charges will hit this wall. If the charge is brought close to that wall, most of the charges will hit this wall and less charge will hit that wall. But if you place it symmetrically at the center of this room, then all the walls will be hit by equal number of field lines, that is flux. So total flux entering this room is how much? This cube is this much. So each surface will be having 1/6 portion of the total flux. These are common questions that come. Each surface, through each surface, how much fraction will pass? 1/6, because there are 6 surfaces. Now the question becomes a little standard. The charge is placed vertically below at point 2, that is center of the base. Just now we have done this. Center of the base, so point 2, half, yes. So point 2, flux through the cube, point 2, flux through the cube, पर आधा तो ऊपर आ पाएगा, बाकी आधा तो चार्ज का बाहर निकला हुआ है, तो rest of the half flux will move out of this. So it would be half of total cube. Half of this. Half of the total flux will enter the cube. Okay, number 2. Number 3. Now the charge is placed here. 3 point is where? Can you describe the position of the 3? 3 point, middle point of any edge. Yes. So this is midpoint of edge. Middle point of the edge. Point 3. What fraction of the total flux will enter this cube? 1/4. Right answer. 1/4. And how is this? I have made an animation of this, 3D animation. Oh, this thing, okay, like this. It will take seconds only to understand. So, point 3, flux through the cube is 1/4 of Q by epsilon naught. This is it. Subset of is, if you have taken the charge at this point, number 4. Number 4 is at the corner point of a cube. So 8 cubes will be required if you place the charge at the corner to cover this charge from all sides. तो cover करने से क्या लाभ क्या होगा? Cover करने से all the flux will pass through those 8 cubes. So through any one cube, only 1/8 of the total flux will pass. That's why through this cube, 1/8 of the total flux will pass. लिख के रखो, मैं I'll send you the animation. देखना. Now it would be 1/8 of Q by epsilon naught. Yes. So इसका साथ लिख के रखो. हाँ. Point 4 point 4 स्टार देगा, लिखो at this stage, ऐसा करके लिखो. At this stage, माना point 4, 1/3 of 1/8 Q by epsilon naught flux passes through each face. Each face is not a good term because 3 faces, so flux 0, no? Through 3 faces which are in contact with. So through each face, which are not in contact, which are, better language, not in contact with the charge, which are not contact with the charge. This is a better. Electric field uniform means it is constant, and a constant thing will come out of the process. So we can write this thing like this, cos theta. So if the electric field is uniform, E will come out of it. And in our syllabus, I am telling you to ease this process. I told you that this is out of the book, just for understanding for a student at the exam hall. We are having only two theories. In theory 1, theta would be 0 degree. Sure, for sure you will be finding this. Theta would be 0 degree. How much would be cos 0 degree? 1. So cos theta will become 1. This is one case. And another case, even easier, theta is 90 degree. So in another case, theta would be 90 degree. This is second case. And for cos theta, it would be 0. So following first case, if theta is 0 degree, then cos 0 degree is how much? 1. So I am writing ds into 1 here, and E being constant, uniform, came out of the integration. Clear though? E came out of the integration, only ds remains, cos theta becomes 1. Theta is how much? 0 degree, if it is so. So integration ds is nothing but s. और integration ds का कितना होगा? s. So समझे yes ना no? Yes. और वैल्यू भी याद रखना yes. Yes ही आएगा हमेशा, all the time. And question is, if theta is 90 degree, second case, तब तो इतना भी नहीं करना है. Then phi equals to whatever it would be 0. So यहाँ तक भी नहीं करना है. Or if it is 0 degree, then the value would be yes na no? Yes. So this thing, this high phi thing is simplified to this. Middle part you need not to do. You need not to do in the exam hall, in the derivation theories. You just write this equals to this. Either or this equals to 0. If theta is 90 degree, you have to just be sure about the angle theta, and for that we have done numericals to understand angles. Okay. Of Coulomb's law. अरे ये क्या है? Coulomb's law का proof. Yes, we'll prove Coulomb's law. Just take a point charge at any point. Keep some space here because we are going to find draw a sphere. भाई इससे तो अंडा ड्रॉ करता तो इट वुड हैव बीन लुकिंग बेटर, बट इट्स माय डेस्टिनी. श्राप है मेरे पे, यू नो, दैट यू कैन नेवर ड्रॉ अ गुड सर्कल. ये लेके मैं जी रहा हूँ. एनीवे, सो प्लीज कंसिडर दिस टू बी अ वेरी गुड sphere, and at the center of that sphere is placed a point charge q. So let write just one line. Let a point charge q is placed. आज का क्लास ना बहुत अच्छा हो रहा है. Placed at the center of a sphere of radius smaller. That's it. Radius smaller. Let us do these things फटाफट. उतना नहीं लिखना है, छोटा छोटा कर. क्या ये स्फीयर का ऊपर ना एक छोटा सा एरिया ले लो तो ds, a patch of area, join center and this area. Shortcut technique, center and this area. So automatically this is radius. Huh? So automatically if you extend it, it will show you the direction which is perpendicular to the sphere. Radius is always perpendicular. So write this as ds vector. Clear about ds vector? Area vector clear. Now comes if the charge is say positive, then let us now talk about electric field intensity. Do we know that electric field intensity for a point charge is always away? How away? Radially away. It means what? Along the radius away. So for this charge Q, along the radius, we have drawn the radius, away will be the electric field as well. What is the angle between ds vector and electric field vector?
0.
Told you, either 0 or 90 degree, and 0 होने से कितना होता है? Yes, that is it. So right here, theta equals to 0 degree. That is it. And now let us write two lines only. How? यहीं पे लिख देता हूँ, इसको साइड में करके यहीं पे लिख देता हूँ, ठीक है? कलर चेंज कर ले रहा हूँ, तुम लोग नीचे ये लिखना. तो देखो, इसमें ऐसे करते हैं कि applying Gauss's theorem, ये लाइन लिखना जरूर. Applying Gauss's theorem, भले you remember the next part or not, doesn't matter, you will be given marks for this line also. प्रूफ नहीं भी हुआ तो भी चलेगा. For applying Gauss's theorem, कहाँ पे? यहाँ पे. कैसे? इंटीग्रेशन पेड गोल एस, इसको लिख दो, हाई फाई को एक बार लिखना है बस, ओनली फॉर द सेक ऑफ राइटिंग लिख लो. इक्वल्स टू हाउ मच? नाउ द गॉसेस थ्योरम, 1 by epsilon naught q, 1 by epsilon naught q enclosed by this Gaussian surface. Who is Gaussian surface now? This sphere. So let us call this sphere to be Gaussian surface. This Gaussian surface. Now let me tell you one thing, that is, I had told you that Gaussian surface, when I was giving you steps how to draw Gaussian surface or facts about Gaussian surface, I had told you that Gaussian surface needs to be drawn through a point, say P, where electric field is to be found, because Gauss's theorem gives us formula of electric field intensity. So for this point charge Q, we are interested in finding electric field intensity at P. Then we did what? Actually, it is a reverse process. We did what? We have drawn a Gaussian surface passing through that point. And if a point charge has to be covered from all sides symmetrically, think of this. A point charge, a point, has to be covered from all sides symmetrically. What should be the shape of that covering area? Sphere. That's why we have taken this as sphere. Now, is it a sphere or a circle? Because you have written it here. That's why I told you to write at least one line, one sentence. It is not a circle, it is a sphere. You have written it. Anyway, तो चलो ये तो लिख दिए एक बार, applying Gauss's theorem. Next line here, I am writing it here. Next line here. Next line implies that. अच्छा ये क्या हो जाएगा? हाई फाई क्या बन जाएगा? याद है? यस ना नो? हाई फाई, यस. एंड cos थीटा इज तो 1. दैट्स व्हाई ओनली ES. ES इक्वल टू 1 by epsilon naught Q. इसमें कुछ करना ही नहीं है, ऐसे छोड़ दो. हम लोग करने क्या जा रहे हैं? वी आर गोइंग टू फाइंड Coulomb's law. That means वही 1 by 4 pi epsilon naught Q by R square formula. So let us put surface area S. S is what? Surface area of this sphere. How much is that? 4 pi R square. Let us put that. So E equals to 1 by epsilon naught Q और ये 1 by 4 pi R square बैठा दो, जिसमें से ये सबको एक साथ में ग्रुपिंग कर लो. इसको ग्रुपिंग कर लो, क्या बचा? Q by R square. अरे आ गया. This is the formula of intensity for a point charge. Applying Coulomb's law. That means this formula came from Coulomb's law. And we proved this from Gauss's theorem. It is an indirect proof of Coulomb's law from Gauss's theorem. That is it. That is theory 2. Electric field for a line charge Line charge means tar, wire is charged. Electric field for a line charge. It has to be a wire. That means, see, this is not style. This actually represents infinite length when we give dots. ऊपर नीचे डॉट माने बोथ साइड इनफाइनाइट. तो क्या एक साइड डॉट हो सकता है, एक साइड डॉट नहीं है? यस, हो सकता है. ये ऐसा भी हो सकता है, ये ऐसा है. तो एक भी साइड में डॉट नहीं है, ऐसा हो सकता है? हाँ, वो भी हो सकता है ऐसे. This wire is of finite length. This is half মানে semi-finite length, huh? Or semi-infinite length, we can also say infinite. Semi-infinite wire. How you understand this? One thing will be dot, that is fixed. Huh? Another end will be dotted. And these are both sides dotted. We may write like infinite minus infinite. Infinitely long wire. For that, we can find electric field intensity at any point P from this wire at a distance r. So we are going to find what? We are going to find electric field intensity E at a point P at a distance r from this wire. Idea clear? Now do the theory. हम लोग क्या करते हैं? उल्टा करते हैं. Theory पहले कर लिए without understanding why are we doing that? Why not sphere? কেউ তো বললে যে sphere, তো তোমার মনে হচ্ছে sphere, যে why not sphere? তার তো आंसर चाहिए, why not? Then only you can remember. चलो अब कुछ नहीं है, 2-3 लाइन लिखना है. चलो डॉट 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 ऐसा सीधा डॉट डॉट हो गया. चलो प्लस चार्ज. चलो चार्ज कितना लिख दो? लैम्डा. चार्ज डेंसिटी लैम्डा. And we understood lambda. Okay. Now we want electric field intensity at any point. इसको ना ज़्यादा दूर मत लेना, पास ही ले लेना कहीं पे. P. We want electric field intensity at P. P point which is at a distance r. Which is at a distance r. Now we will do what? We will draw a Gaussian surface and specially a cylinder of radius r. So the cylinder body should pass through that point. मतलब ये ऐसा होना चाहिए. ये टेढ़ा हो गया. Anyway, ओ भाई क्या? हाँ, थोड़ा छोटा कर लेता हूँ. और कुछ नहीं है. चलो जैसे पहले किया था वैसे करेंगे. कैसे? टेक एनी वैसे हियर. अच्छा, हाउ मेनी फेसेस ऑफ अ क्यू ऑफ अ सिलेंड्रिकल शेप? हाउ मेनी फेसेस ऑफ अ सिलेंड्रिकल शेप इज देयर? सी, हियर इज अ फेस सर्कुलर, हियर इज अ फेस सर्कुलर, 2 सर्कुलर एंड 1 हाँ माने bent surface, curved surface. So 1 curve and 2 circular like this. So how many vector area ds should we draw? 3 surfaces, 3 areas, vector areas. 1, this area इसका साथ perpendicular like this. 1, this area इसका साथ perpendicular outward like this नीचे. And another one, this curved surface. So we can take a small area here and draw this perpendicular like this. Radially outward like this. ठीक? So we are drawing that there. So let me have this to be 1 ds. Take another patch of area here, and it would be ready. It would be away, I mean outward and perpendicular to this plane. This is also ds. ठीक ना? And another surface नीचे, third one, ds. A little dotted. Why? We cannot see that. But when the arrow comes out of it, we can see that. Then form line. This is another ds. Maybe this point is ds1, ds1 vector. Because three different vectors all are same ds cannot be possible. Their directions are different. So name them as 1, 2, 3. That is better. ds1, ds2, ds3. This is surface 1, this is surface 2, and this is surface 3. Three surfaces we understand. Three surfaces. Okay. But this picture is enough. Self-explaining. Chalo. Last 5 minutes and theory khatam. This theory. 5 minutes. And maybe 2-3 lines. We are not writing anything. Just show this thing. This is the Gaussian surface. This is a Gaussian surface of height, say L, length or height L. Let us start from this, from Gauss's theorem. Hi-phi, pet goal S, and then E dot ds. ऐसा ना 3 बार लिखना है. Because there are 3 faces, so how many flux is possible? 3. Flux through upper circular, flux through lower circular, flux through the curved surface. So let us write it 3 times. And in place of writing S, you may write like this, like S1 plus pet goal EDS for what surface? S2 and plus pet goal EDS for which surface now? S3. This is the left side of Gauss's theorem. And what was the right side? 1 by epsilon naught Q enclosed by what? Enclosed by what surface? Gaussian surface. Q enclosed by Gaussian surface. That means this cylinder. Okay. So out of this, I told you 2 easy ways. या तो ES और नहीं तो 0. So 0 would be if the angle between the electric field and ds vector is 90 degree. There are 2 cases where this will happen, has happened. Cases. What are those 2 cases? See, for a line charge which is positive, we learnt in last classes that plus charge के लिए electric field intensity किधर होगा? Away, away. So if it is 0.1 where we are looking for electric field intensity, it would be away from this charge. This is the charge wire and its electric field intensity would be away. So away electric field intensity E and ds are making an angle theta equals to 0 degree, same direction, 0 degree. But similarly E we may write E2. Why? Because this time electric field intensity will change. Why? Because this is at a distance small r, but this patch you have taken a little closer. So the electric field intensity may be same direction, but maybe a little more. So take a little care. If you by mistake you have taken this to be E also, maybe teachers don't deduct any marks for that. But let us be a little bit careful. Chalo, this is 90 degree. Similarly here, the electric field intensity will be E3 away, and this angle is again 90 degree. So E3 and E2 हाजिर हो नहीं, गायब है. Why? Because E3 and E2 theta is 90 degree, cos 90 is 0, so that case happens. So S2 and S3 will have net flux passing through them 0. So this will be 0, this will be 0. So or next line we can write only S1 survives. E dot ds equals to 1 by epsilon naught. 1 by epsilon naught. And let us do something for the right side. You can do this in the same line, but as a beginning, let us do this thing. We have keep this only limited to S1 because others have become 0, and this thing 1 by epsilon naught Q enclosed. What is the Q enclosed by this cylinder? What is the meaning of that? If I say that suppose this arrow is, this white part is a straight line, I should not tear this arrow. This is a line charge. Suppose if I have rubbed this with my t-shirt and have charged it, quite possible. Now this is charged, and if I say what will be the charge enclosed by this box if I insert it inside the box, then you have to consider the charge only inside the box, not outside. I mean the part that is inserted into the box, only this part of the charge you need to take care of, only this length of the charge that is inside this, only this length. Similarly, if this wire is placed and this cube covers, this cylinder covers it, let us only consider the charge only inside this cylinder, here to here. From here to here. What is the charge covered by this? Lambda into L. One length में चार्ज कितना था? लैम्डा. लीनियर चार्ज डेंसिटी वाज लैम्डा. दैट मीन्स व्हाट? वन लेंथ में चार्ज लैम्डा, तो इसका लेंथ कितना है? L. सो L लेंथ में चार्ज कितना? लैम्डा इंटू L. वन लेंथ कंटेन्स लैम्डा चार्ज, L लेंथ कंटेन्स L टाइम्स लैम्डा चार्ज. ओके, सो Q enclosed would be this much. Now let us put the value. What would be this surviving? ES. This is a surviving member. Non-surviving to 0. As a surviving, that would be ES. Nothing to do, easy. So ES would be, let us put the value of S then. Acha, one line you can write, lambda L implies that E into, let us put the value of S. Area of this surface 1. Surface 1 is this curved part. Just now with that copy you have seen it. 2 pi r L. 2 pi r into L. So E into 2 pi r L equals to 1 by epsilon naught lambda L. L cancel. भाई कुछ तो कटा, कुछ तो अच्छा लगा. लाइफ में कुछ तो हुआ ऐसा. तो E equals to this. So let us find. अरे निकालना क्या था वही भूल गए कि what are we going to find? What do we look for applying Gauss's theorem? Electric field intensity. So let us find electric field intensity from here. So therefore E equals to, how much is this? E equals to 2 pi epsilon naught नीचे आ गया. एक काम करते हैं उसको 4 pi epsilon naught बना देते हैं. 2 pi epsilon naught नीचे आ जाएगा. देखो 2 pi है, ये epsilon naught है. So this 2 pi will shake hands with epsilon naught. 2 pi epsilon naught. I am making it 4 pi epsilon naught. तो इसका भरपाई करना है. To make it up, let us take 2 in the numerator. 2 तो बैलेंस हो गया. और ऊपर में बचा कौन इसका? लैम्डा बचा. ओए भाई क्या हो रहा है? ये लैम्डा बचा. देखो this lambda remains in the numerator. So 2 lambda. नीचे कौन बचा? ये r बचा. r 2 lambda by r. And your task would be remembering this. 1 by 4 epsilon naught, 2 lambda by r. This is the electric field intensity at a distance r from a uniformly charged infinitely long wire. Sometimes infinitely long wire is not given. Then what term is given? Only long wire is given. So please consider long wire to be infinitely long wire.